This video is about discrete and continuous random variables. Discrete random variables are countable, while continuous random variables are not countable. Dice roll, coin tosses, and the data from binomial distribution are discrete random variables. The height, weight, time, and the data from normal distribution are continuous random variables. So for discrete random variables, we will find the probabilities over specific values. For continuous random variables, we are looking for the probabilities over certain intervals. And shaded area is the probability for these intervals. So the probability 2 we are using for discrete random variable is the probability mass function. For continuous random variable, we use the probability density function. Let's talk about PDF, which is a probability distribution function. It's about the probability over a specific value. For discrete random variable, any probability over a certain value is greater than 0. And the summation of all the probabilities is 1. No PDF for continuous random variables, which means we cannot find the probability over a specific value. So probability of x equals any specific value equals 0. For example, we have this normal distribution. We want to figure out probability of x equals 4. We do know shaded area under the curve is the probability. The area at x equals 4 is 0, which means probability of x equals 4 is 0. CDF means cumulative distribution function. It's the probability over an interval. For discrete random variables, probability of x less than c equals the probability of x less than or equal to c minus 1. For probability of x greater than c equals the probability of x greater than or equal to c plus 1, which means the probability of x greater than c is not equal to probability of x greater than or equal to c. For continuous random variables, the probability is the shaded area under the curve. So we have a probability of x less than c equals the probability of x less than or equal to c. I show you why now. For this normal distribution, the shaded area means the probability of x less than or equal to 4. This shaded area means probability of x less than 4. Since the shaded areas are equal to each other, so probability of x less than or equal to 4 equals probability of x less than 4. This shaded area means probability of x greater than or equal to 175. For this shaded area means probability of x greater than 175. Since the shaded areas are equal to each other, therefore probability of x greater than equal to 175 equals probability of x greater than 175. But for discrete random variables, it will be different. For example, x follows binomial distribution with 5 as the number of trials, 0.6 as the probability of success. I want to figure out probability of x greater than 3, which means we need to figure out probability of x greater than or equal to 4 equals probability of x equals 4 plus probability of x equals 5. Definitely we can use binomial CDF, but you can also use this summation to show this probability over an interval for discrete random variables. So if we want to look for probability of x less than 3 equals probability of x less than or equal to 2 equals probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2. Definitely we can use binomial CDF, but also you can use this summation to show this probability over an interval for discrete random variables. The probability density function for continuous random variables is greater than or equal to 0. Since shaded area is the probability, then the integral from negative infinity to positive infinity of probability density function f of x dx equals 1. When you're looking for the probability of any intervals, you will use integral. For the first quartile, integral from negative infinity to the first quartile of f of x dx equals 0.25. Integral from negative infinity to the third quartile of f of x dx equals 0.75, which is 3/4. For the median, integral from negative infinity to the median of f of x dx equals 0.5. Mode equals value at which f of x is at maximum.